Introduction to DTFT, discrete time Fourier transform. So what is DTFT? A mathematical tool to transform discrete time signal into their continuous frequency time domain representation. Visualizing the transform, convert discrete sequence to a continuous periodic spectrum. Time domain, here you can see time domain discrete, and a second image is frequency domain continuous. So in first picture, a step plot of point for a sequence that is finite pulses in continuous frequency domain. So here you can see smooth wavy magnitude spectrum, minus 2 pi to 2 pi, highlighting periodicity. Here you can see in first picture image. Here you can see in first image the plotting is sequentially, and in second picture you can see the continuous spectrum. For DTFT, key equations are forward DTFT, x of omega is equal to summation negative infinity to positive infinity x of n e raised to minus j omega n. Here x of omega is input sequence, that is n is equal to integer. X of n is discrete frequency, and minus j omega is continuous spectrum. For inverse DTFT, that is IDTFT, the formula is, key equation is x of n is equal to 1 upon 2 pi minus infinity to integration of minus pi to plus pi x of omega e raised to j omega n dw. So x of n is synthesized sequence. Omega x of omega, here omega is period limits minus pi to pi, and e raised to j omega. So here omega is complex spectrum. The fourth point is fundamental property. Here you can see in image there are minus pi, that is baseband, and plus pi, it is repeating feature. The cross line highlights the basebands. The DTFT is always periodic in frequency with period 2 pi. The core properties are linearity, second is time shifting, third is frequency shifting, and fourth is convolution theorem. The sixth point is DTFT versus DFT. So the context are, here we are comparing DTFT with DFT. So first we compare.
Hello everyone, my name is Athrav Jadhav. So today I am here to explain you the MATLAB code computes the discrete time Fourier transform of finite sequences by using direct summation method. So first line of our code is CLC. So CLC is clear our window. The next line is clear all the previous variables and axes, for example x, y, etc. So to delete that axis, close previous tabs in the MATLAB simulation tab. The next line of our code is define. So define signal is our x equals to 2, 3, 4, 4. So 2, 3, 4, 4 means our signal is at 2, at 1 is 3, at t equals to 3 our signal is 4, and t equals to 4 also 4. So third line of our next line of our code is frequency range. So frequency range is given by w equals to, here w stands for omega. So omega equals to line space 0, 3, 500. It makes the 500 points starts from 0 and ends at 3. So next line is DTFT computation. So DTFT computation is given by x equals to x multiplied by exponential of minus 1 into j into n into omega. So next line of our code is magnitude spectrum. So magnitude spectrum is given as at the subplot 2, 1, 1 means second row, first column, and first point. Plot omega comma abs comma x means at the x-axis and line width of 1.5, and grid is on for this signal. So title of this signal is magnitude spectrum. So x label is frequency in radian per second, and y label is x in e exponential omega. So third and last point of our code is phase spectrum. So this is plot on the subplot 2, 1, 2 means second row, first column, and second position. So this is this plot is about omega and angle x with line 1.5, and title of this plot is phase spectrum. So the label of this x-axis label is frequency in radian per sample, and y label is also phase in radians. And we also see the output of this program in the.
First we will discuss DTFT formula. In this formula, x of n is equal to summation of n stand for minus infinity to infinity, x of n into e raised to minus j omega n. X of k is equal to n stand for 0 to n minus k, x of n into e raised to minus j 2 pi by n into kn, where the n is the length of sample and n is a given signal length. Length means number of sample used in given signal. Let's discuss the given numerical. This is a discrete signal is 2, 3, 4, 4 means 2 is the 0th position, 3 is the 1st position, 4 is the 2nd position, and 4th is the 3rd position. Length of sample is equal to 4 means x of k is equal to n stand for 0 to 4 minus 1 x of n into e raised to minus j 2 pi by 4 into kn, where the x of k is n is equal to 0 to 3 x of n into e raised to minus j 2 pi by 4 into kn. At k is equal to 0, what will be the value of x of k? When we put at k is equal to 0, x of 0 into e raised to minus j 2 pi by 4 into 0 into nth 0th sample value, that is 0. When we put the value of 0 here, similarly put value of 1 here, similarly put value of 2 here and 3 here. When we calculate, x of 0 is equal to 2, x of 1 equal to 3, x of 2 equal to 4, and x of 3 equal to 4. When we calculate, summation of all these terms is 13. At k is equal to 1, similarly we will put the at value of k, x of 1 equal to x of 0 into e raised to minus 2 pi by 4 into 1 into 0. Similarly, x of 1 e raised to minus 2 pi by 4 into 1 into 1, 1 into 2, 1 into 3. When we put the value of all x of 0, x of 1, x of 2 and x of 3, we will give the 2 into e raised to 0, 3 into e raised to minus j pi by 2, 4 into minus j pi plus 4 into minus j 3 pi by 2. To calculate minus j 2 pi by 2, we will use this formula. In this formula, we will calculate by using r is equal to r in bracket cos theta plus I sin theta. When we put the value of minus pi by 2 in this formula, we will calculate for 3 times, that is minus pi by 2, pi and 3 pi by 2. When we calculate 2 plus 3 in bracket 0 minus I plus 4 in bracket minus 1 minus 0 plus 4 in bracket 0 minus of minus 1 I. So at k is equal to 1, answer is minus 2 plus I. Similarly, we can find x of 2 and x of 3. At x of 2, answer is minus 1, and x of 3, answer is minus 2 minus j. From this table, we will calculate and plot the graph of magnitude spectrum and phase spectrum. In this, at value of k is equal to 0, x of k is equal to 13, at 1 minus 2 plus j, at 2 minus 1, at 3 minus 2 minus j. From this, we will calculate the magnitude. To calculate magnitude, formula is under root of real part square plus imaginary part square. Here 13 is the real part and 0 is the imaginary part. To calculate magnitude, we will use this formula, and magnitude is 13. Similarly, we can find all the magnitudes of at value of k is equal to 0, 1, 2, 3 and 1, 2, 3. Similarly, we can find angle. In this, use formula tan inverse of b upon a. Here b is equal to 0, which causes angle is 0, and at k is equal to 3, b is equal to 0 and a is equal to 2. Hence angle is 0 degree. At k is equal to 2, b is equal to minus 2 and b is equal to 1 and a is equal to minus 2. Hence angle is minus 26.56 degree. Similarly, at k is equal to 3, angle is 26.56 degree. We will plot magnitude graph and phase angle graph. In this, at 0 position, at k is equal to 0, magnitude is 13. At 1, magnitude is 2.236. Similarly, at 2 is equal, magnitude is equal to 1. At 3, magnitude is equal to 2.236. Let's plot the graph. This is the magnitude graph of given DTFT signal. We will plot the angle and phase graph. In this, at k is equal to 0, angle is 0 degree. At k is equal to 1, angle is minus 26.56 degree, that is here. At k is equal to 2, angle is 0 degree. And at k is equal to 3, angle is plus 26.56 degree. Let's draw the graph. This is the angle phase graph. Thank you.
Transform in DTFT, application of DTFT signal analysis. It is used to analyze the discrete time signal. in the frequency domain help to understand how different frequency components are used in a digital signal processing DSP. It plays key role of the designing and the analyzing digital filters such as low pass, high pass, band pass, and the stop filter. Communication system. The TFT is used in modulation, demodulation, and spectral analysis of the signal efficient transmission. Audio and speech processing helps in analyzing the sound signals, noise reduction, and the comparison technique like a MP3. Image processing used edge detection, image filtering, and the enhanced technique. System analysis. DTFT helps determining the frequency response of the linear travel and LTI system. Spectrum analysis useful in identifying bandwidth power distribution. This project, the DTFT discrete time signal was successfully computed and visualized using MATLAB. The frequency characteristics of the signal to the frequency domain for better analyze, and the interpretation, filtering, and system design in the MATLAB simulation helped the understanding both the theoretical and practical aspect DTFT effective.